Ever pondered over the intricacies of how chemical reactions really work? Every tiny explosion you see in a chemistry lab, or the rusting of an old iron gate, is a dance of atoms and molecules, executing a complex series of steps we call a chemical reaction. Today we dive deep into this world, breaking down the complex into simpler terms. First, picture a chemical reaction as a grand ballet. The dancers or reactant molecules collide on the stage. As they perform their dance, their bonds break. This breaking of bonds is the first step in any chemical reaction. It's a bit like the opening act of a play, setting the stage for the rest of the performance. The breaking of bonds requires energy, often in the form of heat or light. This energy is called the activation energy, and it's what gets the reaction started. Imagine it as the music that sets the dancers in motion. Without this initial push, the dancers would remain stationary, and there would be no performance. Once the bonds have broken, the atoms are free to rearrange themselves. They form new bonds with other atoms, creating new molecules. This is the second step, the formation of products. It's like the climax of the ballet, where the dancers form new pairs and groups, creating a whole new scene on the stage. Now here's the thing. The total mass of the reactants and the products remains the same. This is the principle of conservation of mass. Think of it as the number of dancers on stage. No matter how they move or pair up, the total number of dancers remains the same. Similarly, the total energy before and after the reaction also stays the same, according to the principle of conservation of energy. The energy may change form, just like the dancers may change partners, but the total amount remains constant. However, not all reactions are created equal. The speed of a reaction, or reaction kinetics, depends on various factors, such as the nature of the reactants, the temperature, and the presence of a catalyst. It's like how different ballets have different tempos depending on the music, the choreography, and the skill of the dancers. To recap, a chemical reaction begins with the breaking of bonds between reactant molecules, often triggered by the input of activation energy. The atoms then rearrange themselves, forming new bonds and creating new products. This entire process adheres to the principles of conservation of mass and energy. And just like a ballet, the speed and outcome of the reaction depend on various factors. So the next time you see a chemical reaction, whether in a lab or in nature, picture a grand ballet of atoms and molecules. Each collision, each bond broken and formed, tells a story of transformation, guided by the eternal principles of conservation. And remember, every chemical reaction is a testament to the intricate dance of the universe, happening right before your eyes.